Now, some measurements, even when we convert to the appropriate unit, may be very, very big or very, very small. For example, let's look at the mass of an electron. So the mass of an electron is 0. kilograms. This is a very, very, very tiny number. Now we need to figure out a way to represent this number so that it's easier to understand. So one thing I want to point out to you before we continue is powers of 10. For example, if I wrote the number 10 to the 5th, 10 to the 5th is equal to 10 times 10 times 10 times 10 times 10. Okay. Powers just mean you multiply a number by itself the same number of times that's in the exponent. So this is 10 times 10, 5 times. Now, every time you multiply by 10, you add a 0 on the right of your number. So 10 to the 5th is a 1 with 5 zeros. I can also have a negative exponent. So, for example, let's look at a very small number. (10 to the negative 5th). 10 to the negative 5th means that I take the number 1 and divide that by 10 times 10 times 10 times 10 times 10. Now, every time that I divide by 10, the decimal moves 1 to the left from the number 1. So this number would actually be 0.00001. As you can see, the decimal point has moved 1, 2, 3, 4, 5 places to the right from the original number 1. Same thing happened here. If I start with the number 1, because 10 to the 5th is really 1 times 10 to the 5th, 1 times 10 5 times would move the decimal 1, 2, 3, 4, 5 times to the right, giving me a very big number. Same as here, 10 to the negative 5th is really the same thing as saying 1 times 10 to the negative 5th. So a positive power means move to the right. A negative power means you need to move to the left. So how can we write this big number, 0.0000931 kilograms, which is the mass of an electron, in scientific notation? So there are several steps to doing this. So the first step will be to move the decimal point until the number is greater than or equal to 1 or and less than 10. So this number has to be greater or equal to 1 and less than 10. In our example, the decimal point is all the way over here. So let's figure out how many where we have to move the decimal in order to get a number that is greater or equal to 1 and less than 10. So we'll move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 times. So once I move the decimal 31 times, I can see that I get the number 9.31. So I'm going to write 9.31. Now, if you notice, 9.31 is not the same number as 0.0000931 kilograms. So we're not quite done yet. So let's move on to step number 2. Step number 2 is count the number of times that the decimal had to be moved in order to get to the number for part 1. So we have to count that number of times. This number will become the exponent on the number 10. Now, what does this actually mean? Well, we have 9.31, and I saw that I counted 31 times that I moved the decimal place. So I'll record that number up here. So with this number 31, I'm going to make it the exponent on the number 10. Now there is no number 10 right now. So what I do here is I take my 9.31, that number I got by moving the decimal point, and I multiply that by 10, and I'm going to raise it to the 31st power. Now there's one more step that I have to do. I have to think about whether I need a negative power or a positive power. And this will be 3. If the decimal point needs to be moved to the left in order to return to the original number, the exponent will be negative. If the decimal point needs to be moved to the right in order to return to the original number, the exponent will be positive. So if we look in this case, well, we have the number 9.31. In order to get back to our original number, the decimal point would have to move to the left. And according to our rule, if we move to the left, the exponent is negative. So I'm going to put a negative sign here next to the 31. So in scientific notation, our number for the mass of the electron is 9.31 times 10 to the negative 31st kilograms. Remember, units are important. Don't forget them. Let's do a few more examples converting from scientific notation to standard notation and standard notation to scientific notation. Let's start with a number. So we will start with 0.0042. Let's convert this to scientific notation. To do that, the first step is to move the decimal point until we get a number between 1 and 10. So we'll go 1, 2, 3 places to get a number between 1 and 10, and that number is 4.2. Now we multiply that times 10 to some power. So here we move the decimal point 1, 2, 3 to the right. So our exponent is going to be 3. And in order to get back to our original number, from 4.2 back to the original, the decimal needs to move to the left, so our exponent is going to be negative. Another example, let's take a very big number. Let's take 873,000. And we'll convert this to scientific notation. So when we do this, again, we need a number between 1 and 10. The decimal point in this case, because none is written, is at the end. So we're going to move this 1, 2, 3, 4, 5 places to the left to get the number 8.73. So now once we have this number between 1 and 10, we have to multiply this by 10. So I get times 10. Now how many places did we move our decimal? We moved 1, 2, 3, 4, 5 places. So it's 10 to the 5th. And in order to get back to our original number, the decimal needs to move to the right, so our number, our exponent, remains positive. So let's look at an example going the other way. So if I have the number 1.56 times 10 to the 8th, and I want to convert that to standard notation, I need to take my original number, 1.56, and this 10 to the 8th, because it's positive, tells me to move my decimal point 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8 will be my new decimal, and I fill in every place here with a 0, and that's my new number. 156 million. Now we can do this going in the other direction. What if instead I had 2.3 times 10 to the negative 4th? Well, in this case, to convert back to standard notation, I need to move my decimal 4 places to the left. Left because this exponent is negative. So I'll write my number 2.3, and I take my decimal and go 1, 2, 3. 4 places to the left, fill in these spaces with zeros, and I'll rewrite my number. I get 0.00023 as my answer in standard notation.